It's like I don't care about nothing, man. Yeah. Oh,
What's going on, home skills? Coach Carr here. This video is about partitions and how to find K, which is part of the formula to find partitions when we're dealing with a certain ratio. So I don't want to take up too much time, so let's get to it. So this is the start of our journey with partitions. So I don't want to use up too much time, so I'll do a little bit of movie magic. Okay, so number one, it's saying what does it mean to partition something? And what it means is to break into segments. So in our vocab, we talk about line segments. It's breaking up something into a bunch of segments. Now consider the following line segment where the point P partitions a segment into a ratio of 1 to 4. So how many sections are between A and P? So from A to P, it tells us that is one section. From P to B, there is 1, 2, 3, 4 sections. And then how many sections are between A to B, which is the full length? In total, we have 5 sections. Now, part D says in relation to the line segment AB, how long is AP? So AP is 1/5 of the full thing. And in relation to AB, how long is PB? So that one would be 4/5 the entire thing. So the next part is they're wanting us to find K, which is going to be what we use in the formulas based on the ratios that we're given. So I don't want to use up too much time again. So for the first one, it says that it has a ratio of 4 to 3. So if I'm trying to find K, which is part of the equation we'll use soon for partitions, I have 4 over 7. And the way I get that is 4 is the first number. That's what goes on top. And when you add them together, that's what goes on bottom. So that's how I got 4 over 7. So the next one, when it told us a ratio of 1 to 5, 1 goes on top because it's the first number. And then on bottom is whatever they are added together. So that would be 6. So the next part under it is they want us to give the formula. So I went ahead and wrote it down. So we have x1 plus k. So what we did above was to find our k's. And then in parentheses, x2 minus x1. So the x1s are going to be the x values of the first number that you're given, unless told otherwise. X2 will be the x value of the second point that you're given. And then...
No, that's it.
And then?
No, and then. That's all I want.
And then?
Whenever we're finding a point, there's an x and a y value. So what we did over here, we do the same thing over here, except with y values. So y1 plus k, and in parentheses, y2 minus y1. So that is the formula that we'll use for partitions. So the first actual problem that we're doing on this video is this one down here where it says point A has coordinates of 2, 4. Point B has coordinates of 10, 12. Find the coordinates of point P that partitions AB in the ratio of 3 to 2. So I am going to do some movie magic so it doesn't take quite as long. Okay, so I'm going to go through this step by step. Now, point A, we were told it has coordinate of 2, 4. Point B has a coordinate of 10, 12. And they want us to find point P that has a ratio of 3 to 2. So we're going to use this equation that we have up here right before it. So x1, y1 is going to come from point A because that's the first one they gave us. Point B is going to be our x2, y2 in this equation. So I did my 2 plus 3 over 5 times 10 minus 2. According to order of operations, anything parentheses have to be done first. So 10 minus 2 gives me 8. You notice that I put it over 1. That's because it has to multiply with this. So numerators, so the numbers up top go multiply together. Ones on bottom multiply together. So that brought me to 2 plus 24 over 5. Now when you add fractions, that's when they have to have the same denominator. So in order to make it so 2 has the same denominator, I had to multiply the top by 5. So now I have 10 over 5. So now 10 plus 24 got me 34, and the denominator stays the same, so I still have 5. Now over here, I'm looking at my y values. So I have 4 plus 3 over 5, because that's what my k is. And in parentheses, 12 minus 4. 12 minus 4 is 8. So now, again, because they're going to multiply, I put it over 1, because numerators together, denominators together. And I get 4 plus 24 over 5. Now, when I add fractions together, they have to have the same denominator. So instead of a 1 on bottom, I made it 5, so I had to multiply the top by 5. And I got 20 plus 24 on top, and the 5 stays the same. So 44 over 5. So you can leave your answer as a fraction. So you can leave it as 34 over 5 or 44 over 5. But if you would rather deal with decimals, you are allowed to. So if you would have made your answer 6.8 and 8.8, that would have worked as well. Now, a little trick when you're putting it in, I already labeled the A and the B. If you know there's going to be a ratio of 3 to 2, you can kind of see basically where it's going to be by seeing, by looking at this ratio. So I know it's going to be broken up into 5 total parts. So if I tried to make it so it was kind of even on each one and break it up. So when I did this, now I have 1, 2, 3, 4, 5 parts. So a ratio of 3 to 2, that means 1, 2, 3. I would be looking somewhere around here. So I know roughly it's going to be here. So my 6.8 and 8.8 is probably correct just by basically looking at that. So the next problem we're looking at is number 5 on page 13. The first one, part A, is saying find the coordinates of point P that partitions the line segment AB in a ratio of 1 to 4. So we are going to be using this graph here to figure out where A and B are. So I'll do a little bit of magic. Okay, so with this problem, I looked at where A was, which was at 1, -1, made that my x1, y1, and B was at 4, 4, and I made that my x2, y2, and K is 1 over 5. Reason being is you had this ratio of 1 to 4, so 1 goes on top, and when you add them together, that's what's on bottom. So here we have 1 plus 1 over 5 times 4 minus 1, because I'm using the formula for partitions. This is for the x values. When I do this, I get 1 plus 1 over 5 times 3, because 4 minus 1 gave me 3. I put it over 1 since I'm dealing with a fraction. And numerators together, denominators together. And I get 1 plus 3 over 5. Now, whenever you're adding fractions, the denominator has to be the same. So I multiply the top and the bottom by 5. So now 5 plus 3 gives me 8. And then the denominator stays the same, so it was 5. Now to my y values, I have -1 plus 1 over 5 times 4 plus 1. Now I have -1 plus 1 over 5 times 5 over 1. And the reason I put it over 1 is because any number over 1 is itself, so this makes it so I can multiply them easily. And numerators together, denominators together. So -1 plus 5 over 5. Any number over itself is 1. So that's how I got -1 plus 1, which equals 0. So I can have my answers in two ways. I can either keep it in fraction form, so 8 over 5, and then my y value being 0, or 1.6 and my y value being 0. So either answer would be acceptable.
Oh, yeah. Yeah, baby. Yeah. Oh.
All right, so now part B. It says suppose A, R, and B are collinear on the line segment AB, and line segment AR to AB equals 1 over 4. What are the coordinates of R? So if you notice, this one doesn't say a ratio of 1 to 4. It actually already has it as 1 over 4. So that's going to make my K value be different. So pay attention to that when I do this magic. Okay, so when we're looking at this one now, our A and B were in the same spots as the one problem above. But our K was different because this was already put over as a fraction instead of a ratio. So since it's already put in the fraction, then our K would be the same fraction. So that's the main difference. But in this one here, when I solve it out, I get 7 over 4. Then on the y side, when I solve it all out, here's all the steps. If you have questions on the steps, just let me know and I will help you in class. I get 1 over 4. So you could have wrote your answers in two ways, either in fraction or decimal form. So 7 over 4 and 1 over 4, or 1.75 and 0.25. So that's the end of the video. So make sure to do for practice page 13, number 4, and 15, page 15, number 10. So since that's the end of the video, we can check this off. Have a good rest of the day, and make sure to like and subscribe.